Here's the video I'm going to make to explain this post frame building or pole barn that I'm planning on building. This is only the framing. I haven't covered it with the metal yet. I'm going to start from the ground and explain what I'm doing here. So let me turn off all these layers, and then we'll start from the existing foundation and show how I'm planning on building this post frame building around what's existing. Okay, so now the only thing I have visible on the screen is the existing building. There was a building, 100-year-old building or maybe older, over this foundation with the floor, but the building's been torn down, and we're trying to preserve the basement or root cellar with the floor, but we want to build a new building around it. So this is showing the new excavation, and this is showing the new footing right here. So the new footing, we're thinking it's probably going to be 2 feet, 2 feet wide around the whole existing root cellar by 10 inches. Okay. Now I did not go all the way tight up against the existing foundation because I wanted to leave a little bit of leeway, and maybe it's going to help the old foundation so it doesn't crumble to pieces. Plus, once the new foundation is poured on the new footing, that's going to give me a nice even number of 24 feet. See if I can hook it right. Yeah, so the new building will be about 24 feet. Now also, what that's going to do by making it a little bit wider, if this old foundation is not completely square, which I doubt it is, if it's not completely level, which I doubt it is, we're just building a new foundation around it. So our new building is going to be square and level. Additionally, I have built this new foundation just a little bit above the old one. You see that? See how it's a little bit above that? The reason I want to do that is because I'm not going to rely on that existing foundation to be level. And when we put the floor together, you'll see why I decided to do the floor above the old foundation, because I want it to be completely independent. Okay. Now, I'm not really 100% sure exactly how these existing stairs go, but it doesn't matter. This is just for the purpose of showing how the new building is going to cover the old building. Okay. So once the new foundation's poured, like I said, it's going to be 24 feet wide. 24 feet wide. And then I went a little bit longer. I went as tight as I could to the front here, but then it's about it's 40 feet, because you see how the foundation is stepped up. And I chose 40 feet because it's a nice even number that'll work out well with my spacing. And it's showing 40 feet 3/16, but that's not accurate. Let's see if I can keep this on the red plane. There you go. So it's 40 feet by 24. Okay. So once this is all excavated and it's all poured, by doing that 40 feet, I had to add this little foundation to carry the floor right here. Okay. So the foundation is poured. Then we come back, and that's when we put the mud sill on. Okay. The mud sill goes around the foundation like this. Now, right here, this is a 2x8 mud sill, and I'll show you why later. Okay. I haven't shown the anchor bolts or anything, but this would get anchor bolts, and it would be the 2x8 mud sill. Now, right here, this part of the framing, it's just floating over the old foundation. Okay. Don't worry about that, because we'll frame this 3 inches or whatever, however high it is above the foundation. We'll frame that in and make it so it rests some way on the old foundation. And this is not a critical bearing point. It's just all it's going to be is floor load. So it doesn't have to be on top of a new foundation or anything. I just didn't want to start demolition on the old foundation. I don't want to demolish any of the old foundation. I want to leave it in place. We're just building a floor over. Okay. So once the mud sill goes on, the next thing that goes on is the posts. Okay. So this is how my posts are going to go. They're evenly spaced, and the posts are resting on the mud sill right here. Okay. And the posts on this side are resting on the new foundation, where the new foundation steps up. And once I turn on the floor layer, it's going to make sense why the foundation steps up like this, because we want the foundation, we want the floor to be where you can walk across it and there's no step up in the floor. Okay. But just look at the posts right now. Now how those are anchored to the foundation is like this, with these like angle iron pieces. And this right here, it would just be a hole that we drill into the foundation. We epoxy in. I just put these bolts in because they were easy to download, but really what it's going to be is a rod epoxied in a hole with a nut and a washer. Okay. And then the posts they'll have the bolts going through the posts and through the angle irons. Okay. So that shows how the posts are anchored to the foundation through the mud sill. The only thing you're not seeing is I haven't drawn anchor bolts in from the foundation to the mud sill, but they would all go in here. Okay. I could draw those in later. Now, the next thing that goes on after the posts are set up and anchored is the floor framing. So here's the floor framing, the new TGI joists. They're 16 inches on center. And I am going to have to put a new girder beam down in the old foundation because the joists, they're not going to span 24 feet without a center girder. So that center girder beam is going to have to be there. And I'm just planning these as wood posts, but they could be metal posts. I'm just planning the girder beam as a wood beam, but it could be a metal beam. The thing is that there's going to have to be a center girder there, and we can't use the old girder framing because it's just too out of plumb. It's just garbage. I can't use it. I have to redo it. Okay, so that's why these new concrete footers are going to be in to hold the posts. All right. And I'm not even sure right now if there's a dirt floor down there or if it's concrete or what it is, but whatever it is, we're going to have to dig down and pour some footers down there to hold the load of the center girder. And the joists are blocked at the center. Okay, so that's the floor framing. Next thing we do is we sheet the floor like that. Okay, so now it's starting to look more like a building. And this is the part where this way we put some blocking under here to keep this attached or some way, just to keep it from sagging right here. That's not a problem. I just haven't drawn it because it's just something so obvious that it will be done on site. Next thing goes on is the wall girts. Okay, this will hold all the posts up, keep the posts from falling down while we're building. Now, the windows, we don't know if there's going to be windows or not. I just drew those windows because this is really the only place the windows could go if there was windows. On the front, there's the double door right there that we talked about. And let's look at the inside. Now we need some wind bracing because if I don't put wind bracing on, this is the wind bracing. All right, see all these diagonal ones? The wind bracing. If I don't put the wind bracing on, what's going to happen is the wind is going to blow on this wall and it's going to want to blow this long wall over. Okay, it could blow from either way and it could blow these walls over because the metal on the outside of the building is not strong enough to resist the wind. So if I don't put that wind bracing on, then the walls could blow over this way. All right. So the wind bracing has to go on. That's why I said if there is windows, the windows have to go right here so they're not in the way of the wind bracing. Otherwise the wind bracing will have to be reconfigured. And this to me seemed like the most obvious place for windows. If there were windows, if there's no windows, then it'll have to be one of those translucent rows of panels up on top or something else. Okay. But if there's no windows, that's not a problem. Those will just get covered over. This is the wall framing. Like, in order for the windows to go in, I have to frame around the inside. Okay. And then you see this is also where I put the intermediate 2x6s all the way down. The 2x6s are going to have to be notched in to the wind bracing, but that's not a problem. That's an easy notch right there. And the whole reason I'm putting these wind braces on is because these intermediate 2x6s received into the wind braces is because above, then I have the trusses. All right, you see that? Now I have a place. My trusses are 4 foot on center. I mean, it's all divided out equally among this 40-foot length. But now I have a place where my trusses sit, and it takes the load of the truss all the way to the foundation. Of course, the trusses that are sitting on top of the posts, that's obvious because those sit on top of the posts, and then that way there's a nice way to anchor that post. Okay. We're going to have some kind of an additional anchor right here, which I haven't drawn in, but that's just an easy, like a Simpson H2.5 hurricane clip, like on a regular house. So that's an easy connection. It's just not drawn there. All right. The next thing that goes on is the knee braces. All right. It's kind of getting hard to see what's going on in here, but these knee braces are like this. See, that's the knee brace. And that's going to go on, and it's going to keep the wall from blowing in this way. See that? The trusses are going to lock both walls together, but those knee braces are going to make it so it's almost like the wind is only blowing against an 8-foot wall instead of a 12-foot wall, because the ceiling height on these trusses is 12 feet. From here, from the bottom of the truss to the floor, it's 12 feet. And I'm trying to keep I just try to keep that locked on the blue axis. There it is. It's locked on a blue axis. And you can see it's 12 feet, like I said. Okay. But sorry about that. I don't know what happened there. Let's go back to here. Hopefully it's still recording. But the knee braces, they're going to help the barn to be stronger. Okay. Now let's look at the truss bracing, which this is the truss bracing right here. And the reason I did that is because it's going to lock everything together better. And the truss braces are right above these knee braces, and they go all the way through. And then I have the diagonal braces up. Okay. And this is all going to lock together. Once I put the roof purlins and the fascia on, it's going to make these braces in the roof serve a function. What they're supposed to do is hold all the roof together and keep it from blowing around and wobbling around. So these are the roof purlins, the fascia. Even though this is a post frame building, we're doing an overhang to keep the water off the panels better, keep it from dripping right up against the foundation. And it's going to cast the water off 2 foot away from the building. Okay. Assuming no wind, of course, but having the overhang is just so much of a better building. And this is how I'm going to hold the barge raft, or if you want to call it that. It's going to be held up by all these purlins, 2 foot on center, 2x6s. And it's a 412 slope roof. Should be pretty easy to walk on. And very strong. And then this is now on the inside here, I plan on framing it like this with these bottom girts up 4 inches. Okay, because what we're doing here, we're leaving place for the new slab. So here's the new slab. Later, after we get this all framed up, the concrete guy can come back in and he can pour his slab. Okay, and his slab will go right up under here, right up under the building. Okay, so when you walk in, it's all normal, and there's the concrete slab here is the same height as the floor. And then however the concrete guy figures out how to interface his slab with the existing stairs, then that way there's still going to be a space down to the root cellar or storage or whatever is down here. But that's how this all ties together. And then once the wall panels go on, they go on like this. Okay, I haven't drawn all the wall panels, but they're going to overhang the foundation. That way, any water that hits it is just going to just go right down there, and it's not going to seep back under the floor. So I don't need an extra piece of flashing here at the foundation because I'm planning on making the framing flush with the foundation so that the panels overhang. So that's the structure. That's how I have the structure. Now we can send this off to the engineer, and if he wants to change anything, he can. And then once I get the approval from the engineer, then I can go ahead and I can model all the panels on all the pieces around the window, if there is windows around the door, put the roof panels on, the soffit panels. So this is a representation of the structure.